The National Electrical Code, or NEC, does not explicitly address whether the actual total connected load can exceed a circuit's maximum capacity. However, it is generally accepted that exceeding the maximum capacity is permissible, provided the actual load does not exceed the circuit's maximum capacity. This acceptance stems from the NEC foundation in the principle of reasonable safety. The code recognizes that the actual load on a circuit is frequently less than the theoretical total connected load. Consider an example where the calculated load on a 20-amp, 120-volt branch circuit serving 13 general duplex receptacles in a commercial office is 2340 volt amps, assuming 180 volt amps per receptacle. This calculated load remains within the circuit's maximum capacity of 2400 volt amps. However, various small office appliances such as printers, copy machines, computers, desk calculators, battery chargers, fax machines, typewriters, and task lighting are plugged into the same circuit. The total connected load, based on the nameplate data of these appliances, exceeds 2400 volt amps. Despite this, the actual recorded average peak demand over a 1-week period is less than 50% of the circuit's capacity. This discrepancy arises because nameplate data represents maximum values, and many office appliances operate intermittently, at different times, and at varying load levels. In such a scenario, exceeding the circuit's maximum capacity by the total connected load does not inherently constitute a violation of the NEC. The crucial factor is that the actual load drawn at any given time remains within the circuit's maximum capacity. The reason the actual load often falls below the total connected load lies in the operational characteristics of many appliances. These appliances do not operate continuously at their maximum rated power. For instance, a printer may only operate for a few minutes at a time, while a computer may only be actively used for a few hours each day. Consequently, the actual load on the circuit is typically significantly lower than the sum of the nameplate ratings of all connected devices. In the example provided, the recorded average peak demand being less than 50% of the circuit's capacity indicates that the actual load on the circuit remains comfortably within the circuit's maximum capacity. Therefore, no violation of the NEC exists in this situation. Understanding the distinction between calculated load, total connected load, and actual load is essential for applying the NEC effectively. The calculated load is determined using specific NEC guidelines, which provide a standardized method for estimating the demand on a circuit based on the types and number of outlets or appliances served. The total connected load is the sum of the nameplate ratings of all devices connected to the circuit. The actual load is the real-time measurement of the power being drawn by the circuit at any given moment. The NEC primarily focuses on ensuring that the calculated load does not exceed the circuit's capacity and that the actual load, under normal operating conditions, remains within safe limits. The NEC provides tables and guidelines for calculating loads based on occupancy type, square footage, and the types of loads served. These calculations help determine the minimum required circuit capacity to ensure safe and reliable operation. When assessing whether the total connected load exceeds the circuit's capacity, it is important to consider demand factors and diversity. Demand factors account for the fact that not all connected loads will operate simultaneously at their maximum rating. Diversity refers to the variation in usage patterns among different appliances or loads connected to the same circuit. The NEC allows for the application of demand factors in certain situations, which can reduce the calculated load and allow for a higher total connected load. However, it is crucial to ensure that the actual load, considering demand factors and diversity, does not exceed the circuit's capacity. In situations where the total connected load significantly exceeds the circuit's capacity, it may be necessary to implement load management strategies or to redistribute loads across multiple circuits. Load management involves controlling the operation of certain appliances or loads to reduce the peak demand on the circuit. This can be achieved through manual controls, timers, or automated load shedding systems. Redistributing loads involves moving some appliances or loads to a different circuit to reduce the burden on the overloaded circuit. When evaluating the safety and compliance of an electrical installation, it is essential to consult with a qualified electrical professional. An electrician can assess the specific circumstances, perform load calculations, and provide recommendations to ensure that the installation meets the requirements of the NEC and operates safely. It is also important to regularly monitor the actual load on circuits to identify any potential overloads or other issues. This can be done using clamp-on ammeters or other monitoring devices. By regularly monitoring the load, it is possible to detect changes in usage patterns or equipment malfunctions that could lead to overloads. In summary, the NEC does not strictly prohibit the total connected load from exceeding the circuit's maximum capacity, provided that the actual load remains within the circuit's capacity. The code relies on the principle of reasonable safety and recognizes that the actual load is often less than the total connected load due to factors such as intermittent operation and diversity. It is essential to carefully consider demand factors, diversity, and the actual load when evaluating the safety and compliance of an electrical installation. Consulting with a qualified electrical professional and regularly monitoring the load are crucial steps in ensuring safe and reliable operation. The NEC provides specific guidelines for calculating branch circuit loads. For general use receptacles, the NEC typically requires an allowance of 180 volt-amps per receptacle, as illustrated in the initial example. However, this is a general guideline, and specific applications may require higher or lower allowances based on the expected load. For example, receptacles intended for specific appliances such as refrigerators or computers may require a higher volt-ampere allowance to accommodate the appliance's power requirements. In commercial buildings, the NEC also addresses lighting loads. The minimum lighting load is typically calculated based on the square footage of the building and the type of occupancy. The NEC provides tables that specify the minimum lighting load requirements for various types of occupancies, such as offices, retail stores, and warehouses. The lighting load must be included in the total calculated load for the branch circuit. In addition to receptacle and lighting loads, the NEC also addresses motor loads. Motor loads are calculated based on the horsepower rating of the motor and the voltage of the circuit. The NEC provides tables that specify the full load current for various motor sizes and voltages. The motor load must be included in the total calculated load for the branch circuit, and the circuit must be sized to accommodate the motor's starting current, which can be significantly higher than the full load current. The NEC also includes requirements for calculating the load of heating and air conditioning equipment. The load is typically calculated based on the nameplate rating of the equipment and the voltage of the circuit. The NEC provides guidelines for calculating the load of both resistive heating equipment and air conditioning equipment. When calculating branch circuit loads, it is important to consider any applicable demand factors. Demand factors are multipliers that are applied to the calculated load to account for the fact that not all loads will operate simultaneously at their maximum rating. The NEC allows for the application of demand factors in certain situations, such as for dwelling units and for commercial buildings with multiple tenants. Demand factors can significantly reduce the calculated load and allow for a smaller circuit size. However, it is important to ensure that the demand factors are appropriate for the specific application and that the actual load does not exceed the circuit's capacity. The NEC also includes requirements for overcurrent protection of branch circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. The size of the overcurrent protection device must be coordinated with the ampacity of the circuit conductors. The NEC specifies the maximum allowable overcurrent protection for various conductor sizes. It is important to select the appropriate overcurrent protection device to ensure that the circuit is adequately protected. In addition to overcurrent protection, the NEC also includes requirements for grounding of branch circuits. Grounding is essential for electrical safety and helps to prevent electrical shock. The NEC requires that all metal enclosures and equipment be grounded to provide a low impedance path for fault current. Grounding conductors must be properly sized and installed to ensure effective grounding. The NEC also includes requirements for the installation of receptacles. Receptacles must be properly grounded and securely mounted. The NEC specifies the minimum number of receptacles that are required in various locations, such as dwelling units and commercial buildings. Receptacles must be installed in accordance with the NEC requirements to ensure electrical safety. The NEC also includes requirements for the installation of lighting fixtures. Lighting fixtures must be properly supported and wired. The NEC specifies the minimum clearances that are required around lighting fixtures. Lighting fixtures must be installed in accordance with the NEC requirements to ensure electrical safety. The NEC also includes requirements for the installation of wiring methods. Wiring methods, such as conduit and cable, must be properly supported and protected from damage. The NEC specifies the types of wiring methods that are permitted in various locations. Wiring methods must be installed in accordance with the NEC requirements to ensure electrical safety. The NEC is a comprehensive set of rules and regulations that govern the installation of electrical systems. It is essential to consult the NEC and to work with a qualified electrical professional to ensure that electrical installations are safe and compliant. The NEC is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are in compliance with the current requirements. The NEC is a vital resource for ensuring electrical safety and protecting people and property from electrical hazards. The proper application of the NEC is essential for creating safe and reliable electrical systems. Understanding the principles and requirements of the NEC is crucial for anyone involved in the design, installation, or maintenance of electrical systems. The NEC is a complex and detailed document, but it is essential for ensuring electrical safety. By following the requirements of the NEC, it is possible to create electrical systems that are safe, reliable, and compliant with applicable regulations. The NEC is a valuable tool for protecting people and property from electrical hazards. It is important to use the NEC effectively to ensure that electrical systems are installed and maintained in a safe and proper manner. In summary, branch circuit load calculations involve considering the loads of receptacles, lighting, motors, and heating/air conditioning equipment. Demand factors can be applied in certain situations to reduce the calculated load. Overcurrent protection and grounding are essential for electrical safety. The NEC provides comprehensive requirements for the installation of receptacles, lighting fixtures, and wiring methods. Consulting the NEC and working with a qualified electrical professional are crucial for ensuring safe and compliant electrical installations. The NEC requirements regarding conductor ampacity and overcurrent protection are paramount for electrical safety. Conductors must be sized to carry the calculated load, and their ampacity, or current carrying capacity, must be sufficient for the intended application. The NEC provides tables that specify the ampacity of various conductor sizes and types, considering factors such as insulation type and installation conditions. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overloads and short circuits. These devices must be sized to protect the conductors without causing nuisance tripping under normal operating conditions. The NEC specifies the maximum allowable overcurrent protection for various conductor sizes, typically not exceeding the conductor's ampacity. Coordinating conductor ampacity and overcurrent protection is crucial for preventing overheating and potential fire hazards. If the overcurrent protection device is too large, it may not trip under overload conditions, allowing the conductor to overheat and potentially cause a fire. If the overcurrent protection device is too small, it may trip frequently under normal operating conditions, causing inconvenience and disrupting service. The NEC also addresses voltage drop in branch circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause appliances to operate inefficiently or malfunction, and can also damage equipment. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to use conductors of adequate size and to keep circuit lengths as short as possible. The NEC provides formulas and tables for calculating voltage drop in branch circuits. In addition to the specific requirements for branch circuits, the NEC also includes general requirements for electrical installations, such as those related to wiring methods, grounding, and equipment installation. Wiring methods must be selected and installed in accordance with the NEC requirements to ensure electrical safety and prevent damage to conductors. Grounding is essential for protecting people from electrical shock and for providing a path for fault current to return to the source. Equipment must be installed in accordance with the NEC requirements to ensure that it is properly supported, protected from damage, and accessible for maintenance. The NEC also includes requirements for electrical inspections and testing. Electrical inspections are conducted by qualified inspectors to ensure that electrical installations comply with the NEC requirements. Electrical testing is performed to verify the safety and performance of electrical systems. Regular electrical inspections and testing can help to identify potential problems and prevent electrical hazards. The NEC is a constantly evolving document that is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are safe and compliant. The NEC is a valuable resource for anyone involved in the design, installation, or maintenance of electrical systems. By following the requirements of the NEC, it is possible to create electrical systems that are safe, reliable, and compliant with applicable regulations. The NEC is a cornerstone of electrical safety in the United States, providing a comprehensive set of standards and guidelines for the safe installation and maintenance of electrical systems. Its rigorous requirements, updated regularly, reflect the latest advancements in technology and safety practices, ensuring the protection of people and property from electrical hazards. Understanding and adhering to the NEC is not just a matter of compliance, but a commitment to safety and responsible electrical practices.